So far we've looked at z-intervals for the population mean, t-intervals for the population mean. Now we're looking at intervals for the population proportion. In this problem, we're told to suppose that 250 randomly selected people are surveyed to determine whether they own tablets. Of the 250 surveyed, 98 reported owning tablets. And then we're asked using a 95% confidence level to compute a confidence interval estimate for the true proportion of people who own tablets. So again, we're going to look at the error bound just like we did with the intervals for means. It's just now our margin of error. Oh, I put error bound mean out of habit. Error bound for the proportion. Our margin of error is going to be the z-score corresponding to our confidence level times p times q divided by n, the square root of all of that. P is the proportion of successes. Q is the complement of that. So the proportion of failures, if you want to put it that way, those who don't own tablets. And then N, as usual, is the sample size. So we're looking at a z-score corresponding to a 95% confidence. That's going to be the same, the 1.96 that we've always used up to this point, times the square root of P is going to be the 98 out of 250. Okay, so if P is 98 out of 250, then Q is 250 minus 98 out of 250. So that's going to be 152 out of 250, all divided by N, which in this case is the 250 people surveyed. So putting this in our calculators, that's going to be approximately 0.0605. So then our confidence interval is determined in the same manner it was before, only now we're looking at the proportion. So it's going to be 98 divided by 250 is approximately 0.392. We subtract the error bound, which is 0.0605 for a lower bound. We take the same 0.392 and we add the error bound 0.0605 for our upper bound. And then simplifying, that's going to give us 0.332 to 0.452. So rounding to the nearest hundredth, we are 95% confident the true population proportion of people who own tablets is between 0.33 and 0.45. You could say also between 33% and 45%, just a different way of writing the same value.